All you do is write code. You don't do any infrastructure, and you just say Spacetime publish, and your code goes and it runs, and we figure out the rest of how to do that. For Bitcraft, the entire backend of the game is only SpacetimeDB. So all the player movement, the positions of players, the positions of trees, the positions of terrain, all the timer state, all of the buildings, everything 100% stored in SpacetimeDB and manipulated by SpacetimeDB. Any game that doesn't do physics is almost trivial in SpacetimeDB.
It's always been a big dream of mine to write my own server-side code for my games because it allows you to do a lot of really cool shit. Unfortunately, it has always felt unapproachable for me as an indie developer, but this has recently changed as I have discovered SpacetimeDB, which promises to solve this problem. In this conversation, I'm talking to Tyler Cloutier, the head of Clockwork Labs.
What I believe the dream should be instead is the cloud is a giant computer. It runs an operating system. I take my program and I run it on that operating system and I'm done. There's something very, very magical about that. As soon as you have to be like, oh, I gotta open up, open up AWS panel again, magic lost.
They're currently working on an MMO called Bitcraft Online and on a product for developers, which is called SpacetimeDB. I'm very excited about this one. We'll try to figure out, is it all hype? Is it real? What's behind it? Let's dive right in.
SpacetimeDB is a general purpose relational database. It's a little bit different than other relational databases.
Can you quickly explain what a relational database is?
Certainly. So a relational database was originally invented by Edgar F. Codd back in 1970, I believe. And essentially what it is it organizes your data, information essentially, into tables. And the nice thing about the relational algebra is that you just operate in the space of sets. And through those operations, you can select certain data, you can aggregate data, and so on. In practice, it's messier, I think, than it sounds. But that is fundamentally what a relational database is.
Everything is stored in a table. So also, for example, the entire game you're working on, it's called Bitcraft Online, right? Everything's just tables.
Yes. So for Bitcraft, the entire backend of the game is only SpacetimeDB. So all the player movement, the positions of players, the positions of trees, the positions of terrain, all the timer state, all of the buildings, everything 100% stored in SpacetimeDB and manipulated by SpacetimeDB. The other thing I'll say about the relational model and relational databases that I think is important is there is one fundamental difference between sort of a Rust or C struct and table. And there's many ways to put it, but one simple way to put it is there's no pointers. So a pointer is a very interesting piece of data. A pointer is data which leaks the physical storage location of your data into your data model, right? So it is a number that is in your data that actually represents where something is stored. The whole reason that Edgar F. Codd came up with the relational model in the beginning was that on hard drives, people were storing data in sort of complex data structures. And the only way to get that data out of those data structures on disk was to write a program that essentially walks those physical locations and collects all the data together. So if you wanted to change your query, you had to change your program, which was not great. And the relational model, what it does is it says, we're not going to put pointers in our data. What we're going to do is we're going to have IDs that can reference other data, but those IDs are unrelated to where the data is stored. And this is, I believe, called, I can't remember exactly the name of it, but it's basically physical independence or something thereabout. I don't remember exactly what the term is, which just means my data is in no way connected or related to the physical location of where that data is. And that's a really important aspect of relational databases. And that's sort of the fundamental difference in some ways between hey, I have just a bunch of structs floating around in my memory and a relational model. I will say it is surprising to me that we, in the 1970s, did this transformation for disks, hard drive disks, but we never did it for memory, RAM, for some reason. It's unclear to me why, and SpacetimeDB is sort of an attempt, in a way, to actually go the final step and also apply it to in-memory data.
God, could it be that it's maybe a little less efficient? Because the way it sounds to me is that instead of knowing exactly where to look, I basically just get an ID and I need to find the correct place, right? So it's maybe a little more expensive to find the place.
There can be, but if you think about what I am saying, it's sort of like saying, well, you can have an ID which is backed by a pointer in a way, right? So, in fact, I'll get into this a little bit, but that is exactly what the ECS model in games does, and I'll have to take an aside to just talk about what ECS is. So, ECS is a model of programming that is popular in sort of data-oriented design that game developers came up with because the sort of collection of pointers memory model was not working very well for games in terms of performance on modern CPUs. So ECS stands for Entity Component System, where an entity is just an ID. So in this case, it's the IDs that we're talking about, like in the relational model. Components are structs, so they're just data, pure data, no functions. And systems are sets of programs that operate on sets of those structs. And the reason that game developers use the ECS model is because instead of hopping all around in memory, which is very, very slow on modern CPUs because of cache invalidation. So you're sort of loading a bunch of memory into your cache and then throwing it all away and going somewhere else in memory and loading a bunch. They can set up an array of all of these values and run over them all very, very quickly because the computer is prefetching them into the cache.
Okay, see.
And so in a lot of ways, actually the relational model for modern hardware is much, much more efficient than the old programming model that we have. So they use, in that case, the entity ID as actually, it is also the physical pointer. But it's not a pointer that's specific to your memory. It's a pointer that's relative to the start of an array. So it's part of the data itself. And in that way, you can kind of squint your eyes, and it's very, very similar to the relational model.
Got it. Okay, I see the similarities to ECS. So, for example, what you're saying on the server side, doing something like looping through all of the players and updating their positions is essentially like ECS, right? Because
That's exactly right. You're just looking at a table, and you're going over all the pages. And as you go all the pages, you do a transformation on each row.
Okay, that was so. What differentiates SpacetimeDB from other relational databases? That's where we left off.
Yes, that's where we started. So the first thing is this part, and it's very important, which is it eliminates all of this. It brings your database into memory, into your program's memory. So you don't have to do any of that coordination where you're translating between like one data model on your server and then serializing it and then going across the network and then unserializing it and then processing all of that. Not only is it a lot easier to handle because in SpacetimeDB, you're sort of implicitly in a transactional context, so you don't have to think about any of that stuff, but it's also way, way faster because you don't have to go across the network to talk to your database and serialize things back and forth. I would say probably the vast majority of the work that a web or game server does is serialization. And so we're eliminating a huge portion of that work just by putting them together. So that's one thing it solves. The next thing it solves is also very important. Because the clients connect directly to the database, we can do all of the serialization and messaging and publishing to your clients directly without you having to do any work. So you write your program, you upload it to run the database, it communicates with the database. Your clients can query the database, and as the data changes, they will actually get pushed updates in real time. And that's relatively complex code that you no longer have to write. It used to be, before SpacetimeDB, that if you wanted to write a game that's real time, it's like, okay, well, in the beginning there were sockets, and you had to connect the sockets and then define a binary protocol for your messages and then send the messages across the network and serialize and deserialize them on both sides. And then you could start writing your program. With SpacetimeDB, you just don't have to do that because we've sort of inverted the relationship with the database and the server. So that's problem number 2 that we solve. And then problem number 3 is because you're uploading your program to run inside of the database, again, we can just do all of the deployment and infrastructure for you. So all you do is write code. You don't do any infrastructure, and you just say Spacetime publish, and your code goes and it runs on the computer, and we figure out the rest of how to do that, of all the persistence of the storage and the state and all of that stuff. And what I will say is I believe that is where the cloud should be. So if you look at like your desktop operating system, for example, you write a program, you call a bunch of syscalls in your desktop operating system, and it handles all the hardware coordination and making sure it gets to disk and so on. It gives you a file system and sort of all of these sort of high-level abstractions. If you then go to the cloud and you want to write a program for the cloud, it's not a single computer where it's like an operating system where you run things. Actually, it's like, oh, I got to do Route 53 and I have to get an EC2 machine and I have to put my data in S3 or Aurora or whatever it is. And I'm picking just Amazon, but it's the same for all of them. It's a collection of like 200 services. And then you have to run Kubernetes, which is going to coordinate between all of your services and make sure they're written, but it doesn't really handle state. So you have to set up all your state and write to specific sort of hard drives and figure all of that out. And what I believe the dream should be instead is the cloud is a giant computer. It runs an operating system. I take my program and I run it on that operating system and I'm done. And so that is the third promise that we deliver on, which is just get rid of the infrastructure.
If you had to write like a list of things that SpacetimeDB is very good and suitable for, and a list of things that it's maybe not so suitable for, how would that list look like?
It's a good question. I would say, let me talk about it in two parts. So I will talk about it first conceptually, and then second, where we are today and like what sort of practical reality do we have in terms of what SDKs and so on are available. Mm-hmm. So as a concept, if you are building an application where all or most of the state is in a relational database already, it's a fantastic use case for it. So a normal web server, that kind of thing, very suitable for it. All of your state lives in a relational database anyway. Now it's just going to be more performant. It's going to be easier to deploy, and you're going to have to do less work. That's triply true for the same application that does any real-time synchronization with clients. So if you have live updating data, for example, you have stock tickers, or you have people doing like sort of a multiplayer application like Figma or something like that, where you have state and you want to see it updating in real time as other people doing it, that is going to be also very, very suitable for SpacetimeDB because we're going to do all of the synchronization for you. You're just going to write queries from your clients. That kind of the ultimate form of that is in some sense a game, right? So a game is all of that plus you have state in your game server, and then you also need to do real-time synchronization. So any game that doesn't do physics is almost trivial in SpacetimeDB. So if you want to make a chess game, or in our case, an MMO, I would not call it trivial per se to make an MMO, even with SpacetimeDB, but it makes it a hell of a lot easier. I will say that. That is also very suitable. The things that are the trickiest to currently do in SpacetimeDB right now, or just in general, is if you have to do a physics simulation. So let's imagine you wanted to use the Unreal backend physics simulation and all the pathfinding and so on, and you wanted to have your state stored in SpacetimeDB. What you really need to do is you can't do that physics simulation inside of SpacetimeDB using the Unreal Engine's APIs, partially for licensing reasons, partially for technical reasons. So what you'll have to do is do the Unreal physics sim outside and then sort of publish changes into your SpacetimeDB state, which then you can synchronize with clients. You can, of course, do your own physics simulation inside of SpacetimeDB. That's not a problem. We have people that are doing that. But it's difficult to pull in sort of external things. So that's like conceptually what works in SpacetimeDB and what doesn't. It's really good at things like social networks, where something like, for example, Twitter, if you wanted to make something like that, or real-time chat, something like Discord is actually sort of perfect because you have this real-time chat, you have complex permissions, and I can talk about the permissions model later, where you really need to be very granular about things and you need to have complex relationships like, if I'm friends with this person, then I can edit this. If I'm friends with this person and I am an owner of this server, then I can add a tag to them or whatever it is that I need to be able to do in Discord with complex permissions. That is something that works really well for SpacetimeDB. That's sort of conceptually where it is. I can then talk about sort of where we are today. So one of the current limitations of SpacetimeDB, which we are rapidly working on fixing, is that you cannot, from within what we call a server module or the piece of code that you upload, you cannot make web or connections outside of it. So it's sort of this pure blob of code that runs fully within the database. Very shortly, we're going to be releasing a new feature which will allow you to do HTTP calls from within the module. And that frees you up to do, I want to send an email, or I want to call the Stripe APIs, or some kind of a thing like this. That's the type of thing that right now what you do is you actually spin up like what we call a sidecar service, and you subscribe to the data and you sort of relay things out. But that is unfortunate. You should really be able to do that inside. And then the other thing is we want to provide more SDKs. So right now we don't have a Swift SDK. We don't have an Android SDK. We don't technically have an Unreal Engine SDK, although that is coming very, very soon. So for people out there who have been looking for that, it's coming. I suppose lastly, we'd like to do more in the way of providing libraries to people. So physics libraries, if you need to do that, or, hey, I just want to make a chat application. Can I pull in a chat library? And then I just have all of that stuff ready to go.
So I roughly know how it works. I've done my research. I've tried to build some stuff with it, right? But like for the people who haven't seen it before, maybe can we quickly explain how you use it? Like, let's say I want to start building with it. Like, what are the main concepts I would have to know and understand to start building?
Gotcha. So the first one is the one we talked about a little bit, which is the module. So the module is the sort of ground truth of your application. It's all of the code that's going to run inside SpacetimeDB. It defines your database schema. And the reason for that is we want the types of your schema to match directly with the types in your code. So that always when you're dealing with the data in your database, you have a typed version, whatever language you're using. So that currently is in WebAssembly. We are going to be adding more languages to that. We're also going to be adding TypeScript. So you'll be able to just write your thing there. Right now, today, you can use Rust and C#. So in your module, you'll define your set of tables. Your tables are just sort of, it's similar to like an ORM, the way you would define a table in an ORM if you're defining it from a code first perspective, where you set up a struct and then each field would be a column. And then you can also add different modifiers to that, like this is a primary key, or this has an index, or this is a unique column, and so on. And you can also add indexes to the overall table, and that kind of thing. So that's one thing. And then we have the concept of a reducer. And a reducer is a function that you write inside of your module, which is exposed to clients. So this is sort of like a public API for your application. And fundamentally, it's kind of like an RPC call. So you have your client. They're going to call your reducer. Your reducer is going to execute. It will modify rows in the database. It will check authentication. It'll check authorization. Can this person do this type of thing? And then just like you would on your normal server, pretty much. And then it will make modifications to the database, and then it will complete. Notably, reducers are atomic. So what that means is they run in a transaction. And if you fail for any reason, so if you return an error or you panic or something like this, that transaction will get fully rolled back and nothing is applied to the database. So if you're going through and you have very, very complex logic, and then at the very end you do some kind of assertion and it didn't turn out the way you expected, you can just assert that and you'll roll everything back. And this is really, really important in a lot of security scenarios where you don't want people to get your database out of sync or in a sort of a bad state. So you always want to know you're fully transitioning from state A through a valid transition into state B. And there's no halfway point. And the example I would give of this is a lot of MMOs historically have had gold loop bugs. And there's a lot of reasons for that. But one of the main classes is incomplete transitions from state to state. So if I am trading with you, the way you'd program that is you take my inventory items, you might put them in your inventory, and then delete them from my inventory. But if you put them in your inventory and then a user figures out a way to throw an error and never delete them from my inventory, you've got a gold loop bug.
Yeah.
Or worse, you did it the other way around and I deleted the items from my inventory and put them in your inventory. And now I've got a problem because I've got customer service being called all the time about people losing their items.
Right. And you did not have those kind of problems in Bitcraft Online so far, or did you at least not being caused in this exact way, I guess?
Yeah. So we cannot possibly have gold loop bugs of that character. We actually have had gold loop bugs, but they are of the character in this case where we had an integer overflow. People figured out how to do that, and we resolved that. So I guess that takes me to the next part of understanding how to use SpacetimeDB, which is publishing a module. So if you get your module, you define it, you get all your functions ready, what you can then do is you publish the module to the database. So that just is Spacetime publish. That's a command that you run on the command line. Up it goes to the database. One of the really cool things that we can do is we can actually modify the code of your application that's running in the server without disconnecting any clients because they're connected to the database. So we can swap out the logic of your application and nobody is the wiser. So when we had gold do bugs, we could very easily just change the reducer code and republish the module, and we didn't have to take the game down or anything. So you can do it like 30 seconds after you discover the bug.
Oh, that's crazy.
Right. Which is pretty exciting. So that's I suppose the second part. And then the last part is clients. How do they interact with the database? So we already talked, they can call reducers. That is actually the only way that they are able to modify the database state. And this is pretty important because stored procedures have been a thing for a long time. They have, a troubled history of being able to operate them easily. Partially that's because they're all separate and who knows who updated which ones when, right? In SpacetimeDB, you have the whole module. It's your whole program. You just upload it. It's the whole version. It's very easy to maintain. But then also, the permissions are very complex. In something like Postgres, you have user role-based permissions. So I'm not going to give my users access to the tables. I can kind of try to set things up so it's maybe okay, but there's a lot of security problems with that. You have SQL injection and so on. So in SpacetimeDB, you actually cannot modify the data as a client unless you call a function, which is conceptually almost exactly the same as how you've set up your servers in the past, right? Typical server sits in between your database and your clients. And really all that it functionally does is reduce the set of operations that you can do to the database. It doesn't usually increase them in any meaningful way. It just sort of eliminates the bad ones.
Okay, that's where the term reducer comes from then.
It's actually not, although maybe it should be. It does only reduce. So the reason it's called a reducer, I actually stole that from React Redux.
Okay.
So the reason it's called a reducer is you take the database state and a set of arguments, or in this case, a request, and you reduce like a map reduce. You reduce that request into the database state and you get a new state. And you sort of just do this one after another to transition from valid state to valid state as you go. And that's actually where the term reducer from React Redux comes from originally, where you're sort of taking your state and you're transitioning it through a bunch of reductions, if that makes any sense.
So users can write to the database using reducers you wrote that kind of verify if you're allowed to write and what you're allowed to write and so on and so forth. How do clients get data from the database?
Okay, so this is a great question. So clients get data from the database by subscribing to the data. What this essentially means is they make something like a SQL query against the database. But the interesting thing about that is it's read-only, of course, and then also we do streaming data. So it's not just that you get the result of the database, but any time that query changes, you get the changes to that query as well if they match your query. So you could say select star from players where position affected, it would be a longer query, but where position is around my character. And then anytime a player walks in or out of range of my character, I will hear about that player on my client. And what it lets you do is basically create your client, make your client sort of a read replica of the server's database state. And the cool thing about this is that not only can you do it for your normal game clients, but now you can have all kinds of clients, right? So you can have a client that's an admin client, or you can have a client that's an AI agent client, and it subscribes to different things and it sends different RPC calls, but you didn't have to write any new server code. So historically, I made my game client. Well, that's the only client that connects to it because the server needs to know what data do I send it. And so that's usually built into the server. And with SpacetimeDB, now it's actually built into the client. So different clients can have different things, and you don't have to write another line of code to be able to do that. It's sort of like the difference between GraphQL versus a regular API thing that you would set up in your website, right? If you have an API, you got to think about everything from the beginning that you might want to query from your API. And you're sort of rebuilding a query engine in a sense when you define that API. And GraphQL says, just let the clients define what they want. And we will determine if they can do that. So then that brings me to permissions on read permissions. So a couple things with read permissions. One is you can have private tables. Those cannot be read by anyone. By default, tables are private. So you have to explicitly say, I'm going to make them public. If they are public, they're subject to row-level security rules. And what that is essentially is you write a view in your server, which defines what clients are allowed to query, and it restricts the set of them. There's other ways of doing that as well, and we want to add those as well. So you can also imagine basically a function that you would call that's written in procedural code that sends data down to clients when you call it and keeps that data up to date. That is really cool. It's really useful. There are certain situations in that version where it's not performant enough. Basically, if you do scanning and that kind of thing, because you have to calculate the dependencies of what data has changed, you might have to send more than you actually really truly need to. And if you define it as a query inside of your database, we can actually take the derivative essentially of that query and only send you the changes that are happening. So we're doing both, but that is how you define the read. The read queries the read permissions in SpacetimeDB.
Got it. But basically, the simple answer is you subscribe to the data that you want to have, and then you automatically receive updates. Plus,
that's correct.
Plus a couple of caveats for the specifics and security stuff and so on. Where are the limits of this entire system? Like, for example, you mentioned the entire thing is stored in memory, right? So the entire database is stored in memory. So does that mean RAM? Does that mean I'm sort of limited to 8 to 64 gigabytes or something, or what's sort of the limit on that?
Yeah, it's a good question. So right now, SpacetimeDB, a single database, is limited to the RAM of a machine. That is to say, the whole database lives in RAM. Important points about that. That's how it is today. There's nothing that would prevent us from also writing it to disk. That's just the way we have written it, because we knew for games, like, you cannot afford to add a bunch of random latency. But if you think about RAM, it's just a cache for disk, which is just a cache for S3. So you can go all the way back to whatever you want as a backing store. We think you can achieve an incredible performance with RAM. So that is what we've restricted it to for now. I think the way we would add allowing people to write to disk is we would, by default, do RAM, but then allow you to specify on a table, this can be written to disk. So for example, if you have logged out players, you're not going to be, when you'll pull them into RAM once when you log in. So you'll move them from the logged out players table and put them in the logged in players table. And the logged in players table will be super speedy because it's fully in RAM. So there's no problem there. And we can even do complex things like, sort of advanced caching. Like, actually, you just put all your tables as hard drive tables, but it's fine because we are intelligent about which ones we have loaded into memory. The other thing I'll say is the limit of RAM is actually not as limiting as you might imagine. You mentioned 64 gigabytes, but you can regularly get a machine with 1 terabyte or 2 terabytes of RAM these days. It's actually not very complicated. It's not much more expensive than you would normally have if you needed 2 terabytes of RAM anyway. So you're either getting a bunch of different machines or one machine with a bunch of RAM. And then the last point I'll make about that is that your applications can comprise multiple databases, right? So there's no reason you need to have one database. Bitcraft actually has 10 that it operates on top of, where we have sort of a database that keeps track of the overall game state. So things like usernames, anything that needs to be global to all players. And then for the sort of the physics interactions in the world and the movement and things like that, those have a region database, and that serves that particular region. And so you can move from region to region.
Okay, so that's I was about to ask
how you can scale SpacetimeDB horizontal.
So let's, for example, say I would make a session-based game, right? Where maybe I would have a matchmaking server / database, and then could I spin up a new module for every session so that
Okay, so this is a great question. Let me tell you how it is now and how you would do it now, and then I'll tell you how we want it to be. So right now, if you had that kind of a thing, what you'd do is you'd have some kind of service on the side that would spin up the sort of the matchmaker module, and players would connect to that, and they'd make matches. And then when you created a match, you would call the SpacetimeDB API, and you'd spin up a match-based database just for them, and then they would connect to that match, and they would do their match. And then when it was done, you archived it or threw it away, whatever you want to do with that data at the end of it. And that would write back into the matchmaking server. What it should be, and what it was sort of always intended to be, is actually from within a database, you can start up another database. Very similar. I mean, these are not new ideas. It's the same thing that Unix did in like 19, whatever the heck, where you should be able to spawn a new database from within a database programmatically at runtime dynamically. Maybe even fork a database. So just like you can fork a Unix process, you should be able to fork a database. And so the way you would do it then is you would just, in your matchmaker, the matchmaker would decide that a match has been created, and you would spin up a database, and then you'd have your clients connect directly to a database. No external service needed to spin databases up and down. So that is how you do a matchmaking thing. And I should also note, we have intermodule communication for Bitcraft. We haven't released it live. We want to make sure we dial it in for everybody before we do that. But you can send messages between databases. So what it really is it's actually an actor system. So sort of the actor model. Much like Scala actors and Scala Akka actors, I should say, where you can send messages between different actors. In SpacetimeDB, each database is an actor, and you can send messages between them as well.
Because obviously, if you run it on multiple modules, that would probably also mean that you don't have to run everything on one machine, right? You can...
Certainly.
Yeah.
And we do. Yeah. For Bitcraft, we run it on, I think, 9 machines.
That's still not that much for like an entire giant MMO world. That's still...
It's true. Well, we've eliminated a huge amount of the work that normally is done, which is all the serialization between the database.
So that was the memory limitations, like for the compute limitations. How expensive can you make a reducer? Should they always be like very short, or can I have reducers run for like multiple seconds, or what's kind of the deal with that?
Yeah, so this is a good question. Sort of a nuanced answer. So right now, the way that SpacetimeDB works, we've actually tried several things. The fastest one so far is just big old lock on the database, do your reducer, release the lock, continue on. And because the code is actually executing in memory next to your data, your transactions are typically quite short. So something like a microsecond or thereabout. You can, of course, write whatever logic you want, so it can get up to milliseconds. If you've written things very, very poorly, you can get up to seconds. And that will not allow others to write to the database at the same time. We have not had that problem. In the future, we certainly plan on doing multi-version concurrency control for the database state. So as transactions are executing, other ones can be executing at the same time. And as long as they don't conflict, they will both commit. We actually implemented that originally, but what we found was very quickly the bookkeeping of MVCC can actually slow you down more than it speeds you up.
Yep.
And you want to be careful about that, especially since on a given machine, a lot of the work that you're going to be doing is actually not writing to the database or running your reducers at all. Most of it is computing subscription queries, because that's an n-by-n problem. If you have one user next to 9 other users, then every time anybody moves, all of the other users have to hear about it. So you have, 100. If you have each person making one change per second, you have 100 messages per second going out.
I see.
So you just have to be cautious about that. One thing you can do for that is, although we would run your writing, like your mutating part of the database on one machine, in principle, we could have multiple machines actually serving the subscription queries that are replicas, right? So those don't have to happen on the same machine. And in fact, we plan on doing that as well. So that would allow you to scale up your game even further, or your game or application or whatever you're building much further, because you're doing all the mutations and you don't have to lock the database or do anything to read the data. You just do them.
Got it. So for the time being, it's a better idea to basically keep the reducers short. And what I've already sort of heard out of earlier answers is that the way you can kind of get around that is by connecting your own machines to the server. Like, let's, for example, say you have AI agents or something that are a little more expensive to run, then you just run them on separate machines that connect to the database.
That's exactly right. So I think we do this in Bitcraft maybe for some AI. So I don't mean AI like LLMs. I mean traditional game AI. We do some logic on a separate stateless machine, just to make it so that we can do kind of whatever pathfinding complex logic we want. And then that will subscribe to data like any client and then write data like any client. It's just in this case, it has different permissions because we know that it's a special client.
Obviously, the dream, like if I can add something to the developer wish list, which I'm sure is already quite long. Obviously, the dream would be to be able to spin something like this up on the cloud without having to worry about it. Just be like, okay, this is like one of the, like maybe a virtual machine connected to the database. I don't have to worry about it. Run that for me. Whatever.
You mean the sort of the sidecar type thing?
Yeah, exactly. If I like, for example, let's say I have some expensive AI stuff to run that I don't want to block the database with that,
sure.
or for example, one other example I can come up with is I have a level generator that every day generates a new level, and like the generation, I don't know, takes 10 seconds or something. I don't want to block the database.
I want to clarify. So if you can do it in SpacetimeDB, you can already do it today. You need intermodule communication. So what you would do is, so we have the cloud. We have a cloud service called Main Cloud. It is currently free. It's going to have a free tier. We're going to have probably a few other types of tiers as well. But what you can do is you can just say Spacetime publish your main database, and then Spacetime publish your sort of side database and set it to be in memory only. And then that will just be there, and it will be sending messages between your real database, sort of your core database, and your expensive AI database. The two things that you're missing today to be able to do that are intermodule communication, which we only have internally.
Got it. Okay.
And you are missing the ability to do API calls, because maybe you want to call out to OpenAI or something like that.
Right. So I could, for example, I could spin up another module, and that module generates a level for 10 seconds, and nobody cares because nobody's connected to the database, and
that's right.
The two databases are connected. Yeah, I see. Okay,
that's exactly right. And one thing I'll say is that it's in general a good idea to not do a lot of work on your servers without releasing logs and things. So a lot of times what people will do is they'll open an interactive transaction with something like Postgres, and they'll do a bunch of round trip times. So, like, oh, I'm gonna like get this user out, and then I'm gonna modify this thing, and then I'm gonna get this other piece of data out, and I'm gonna modify this thing. That whole time, everything that's touching, if some other writer comes through, you're locked on that. So you have to wait however many hundreds of milliseconds to be able to do that. So if your workload, actually Tiger Beetle had a really interesting video about this recently. But if you have a workload where it's at all the Pareto distribution, where most of your users want to access one particular piece of data, for example, a popular YouTube video where everybody's liking the same video, well, then you're going to have a really bad time, because every one of your web servers is opening a connection to Postgres, talking over an interactive connection, locking that count while that's happening, and then releasing it. Whereas in SpacetimeDB, because you're so much closer, there is no round trip time, and you can do things much, much faster.
Okay, interesting. That's interesting. I want to list you a couple of the ideas I had of things I could make with the Spacetime, and just hear your thoughts on it. The first one that came to my mind is just leaderboards. Like I had a look at your black hole IO example.
Yep.
It was too complicated for me, and I need like a little more hands-on experience. But like, surely I can make leaderboards with this. So that's my first SpacetimeDB project is just a leaderboard. But what excites me about it is that I can obviously customize it. Like, for example, I can add a timestamp for when it was added. I can add verification. I can, for example, hide the entire leaderboard and say this only becomes visible at the end of the month or something.
Right.
Then also, like what I mentioned earlier, like the daily levels. For example, every day the server spits out a new level or something. Also, another thing is analytics. I'm sure you also use Spacetime for analytics in Bitcraft, right?
We do. So a little bit of actually, before we go into that, I will want to say there is, for our game, externally made, not actually by us, a website called Bitjita. So it's BITJITA. I think it's .com. And they have built leaderboards for our game. So we didn't even have to do that. That's one of the cool things, is because it's so easy to use SpacetimeDB. Other people have built sort of live updating data leaderboards for us. So you can actually see who are the top players in Bitcraft and what are they doing. And they've also built pretty complex things like they have a marketplace tab where they'll compute arbitrage opportunities. So they'll basically say, hey, there's this person selling this for 30 gold in this area. and this person buying this for 40 gold in this area, and they're this far apart. So you can look at the distances versus price difference, and it will tell you like what is the best arbitrage opportunity, which is pretty incredible. And I have to say, very excited
And do you
to see people do that.
Do you just allow them to connect to your database, or how do they get the data?
So all clients do already connect to the database.
Okay.
They're restricted in what they can see with row-level security rules. Right now, we probably allow people to see more than we should, but that is a business decision. It's not a decision of
got it.
Technical requirements.
So they just have a game client running somewhere and getting all the data from that to update there.
They have their own client. It doesn't have to be a game client.
Okay.
So it's not our game client. Like our game, it's whatever game, and they're just subscribing to the data with their own set of queries that they've determined, and we determined whether they can or cannot see the data.
Okay, got it.
But this is one of the really cool things is people can build off of your game without having to make a bunch of complex documentation about what the APIs do. It's self-evident from the. You can read the SpacetimeDB documentation instead of having to build a whole bunch of Bitcraft specific API documentation and all of that stuff. And then, like I said, if you haven't built in the particular WebSocket protocol, they have to use like a hacked normal game client. It's much, much harder to build a leaderboard for a normal game than it would be for Bitcraft because of SpacetimeDB.
Interesting. Which sort of changing direction here for a second again, but also an interesting topic is verification, how you identify users. Because, for example, I could also imagine scenarios where I'm like, I don't want just anybody to be able to see this data and to call these reducers. Right. For example, I only want Steam players to be able to connect to this. How would you do something like that?
So the way we do this is SpacetimeDB has built-in compatibility with OpenID Connect. Are you familiar? Well, I suppose for our listeners, I'll just briefly go over what OpenID Connect is. So OpenID Connect is effectively, it's what you see when you see like sign in with Google or sign in with Facebook or sign in with Apple or whatever it is. That is all going through OpenID Connect. It's built off of the OAuth 2.0 protocol. Notably, OpenID Connect is to be distinguished from OpenID 2.0, which is not the same thing, and also OpenID and OAuth 1. So OpenID Connect is built off of OAuth 2.0. It's a bunch of JSON web tokens that get passed around. But what it allows you to do is have somebody sign into your game with a particular identity issuer. That issuer can be Google, it can be you, it can be what we're about to launch very soon called Spacetime Auth, which is sort of just another auth provider that's integrated deeply with SpacetimeDB, and you don't have to worry about it. Like you don't have to think about how that works. And then inside of your module, you can get access to the issuer. So you can find out who issued this token and restrict connections to only issuers that you approve. When clients connect, be it by HTTP or by WebSocket, you can check on connection that they have the appropriate credentials, and if they don't, you can deny the connection.
And does that also support verification via Steam, for example?
So Steam is interesting because it uses OpenID 2.0. The answer is a little bit more complex because of that. So OpenID 2.0 is different from OpenID Connect. It's like the older version, and they never updated it. I guess because they're Steam and they can do what they want. But that's the situation. And so SpacetimeDB doesn't support that by default, but we would like Spacetime Auth to do that. No matter what, you can always get around it. You can do it yourself. So for example, you can be your own issuer, issue your own tokens, and your issuer on your own servers can do whatever dance they want to do with Steam to make sure it works. We do something like this for Bitcraft because you can sign in. We have to verify that you have bought the game on Steam to be able to play the game. Yep. So we already do this type of thing. That is going to be much, much simpler when we release Spacetime Auth, which will have built-in Steam support.
That goes on my wish list as well. Authentication with Steam. Because obviously, if players are already logged into Steam, they don't want to log in again into something else.
Yeah, exactly. I mean, that doesn't make sense at all. And I think what we're trying to do is we looked at, so we've been at this now for, I suppose, 6 months or so in terms of seeing what happens after 1.0. We've looked at what people have been doing, And our number one goal is anything that people have felt the need to spin up their own infrastructure for, or their own services, or whatever that is, we should have the way for them to do it just directly in SpacetimeDB, because that is really the magic. When you can just Spacetime publish and your app is just working, there's something very, very magical about that. As soon as you have to be like, oh, I gotta open up, open up AWS panel again, magic lost. So we're just trying to hone in on that so that you never have to do that. That's the goal.
Yeah, I'm very on board with that vision. Obviously, time will tell how realistic of a vision it is. I hope that it is.
I think it can be much more real than it is today. So we're gonna
for sure.
do it.
Yeah, for sure. I talked to Eric from Photon recently. I'm not sure if you saw that podcast.
I haven't actually. That one I definitely want to watch.
Yeah, it was an interesting one. I briefly mentioned SpacetimeDB or something. He didn't specifically talk about it. I don't want to put words in his mouth, but sort of reading between the lines, what I heard from him is that he's a bit skeptical about the efficiency of these generalized solutions, like these solutions that try to do it all right. It's like obviously SpacetimeDB feels like a very generalized solution. It can do kind of almost anything except for maybe at the moment physics and so on. Wondering what your thoughts on this is. Do you see Spacetime as a very general platform? Do you see it as a specialized platform?
So I think there's two ways to do generalized platforms. And one of them is troublesome. And one of them I think can be what it promises to be. So I think one way to do a generalized platform is to say, hey, we're going to be a Swiss Army knife, and we are going to have all these appendages, and you want a multiplayer module, we'll add that on, or you want leaderboards, we'll implement leaderboards for you, and we're going to do all of this stuff for you. And then we'll have a separate thing for this. I would say AWS is, for example, one version of that, where if they need something new, they just sort of they append to it in this kind of way.
And then when you go into their backend interface as a first-time developer, you get a stroke because there are so many.
But you cannot deny that it is not general. There is something for everyone in there. The other way, I think, to do a generalized solution is to think really hard and try to boil the problem down to, and it doesn't always work. It's sometimes there is no general solution. It's just the situation is different. It's just very, very complex, and you can't actually do it. But sometimes, rarely, occasionally, if you think very hard, there is the appropriate abstraction that gets you so far. And I guess the analogy I would use would be files in Unix, right? So they added system, standard in and standard out. And they said everything's a file, and we're going to have these small programs that just manipulate files, and the network is a file, and everything's a file. And with Plan 9, they wanted to go even further and make everything a file, even more so. And that is something that bought them a huge amount of success. It was a really good abstraction to get a lot done. And I would like to believe, and I do believe, that the relational model has proven itself incredibly versatile over the last 50 to 60 years. And SpacetimeDB is actually not even very innovative in some ways. Mm-hmm. It's just taking it just the last mile where it needs to go to be able to bring that abstraction sort of into the operating system level. So, previously Unix, you got files. In SpacetimeDB, it's basically an operating system. You take a program and you run it. But it manipulates tables instead.
Yep.
And that lets us do all the things like queries and real-time synchronization and mapping the data directly to your structs, as opposed to being I have a file and I got to apply a binary format to it and all of that stuff. So he may be right. I'm not sure. But I believe that this is an abstraction that has legs and that actually can, in a lot of ways, solve a lot of problems. There are things that we can do to make it better. So that I think it hasn't filled out the whole space yet. For example, one of the things we could do, we do not currently do, is we could take your server code, the module, and we could actually execute SpacetimeDB on your client as well. And then we could do client-side prediction, because we have your server code and we have a copy of the game state, or at least a portion of the game state. And if you have a reducer that doesn't access any state that your server has, but your client does not have. So you would mark like a reducer, like, hey, this is predictable. Then on the client, you can actually just execute that and find out what would the server have said if it's got the same state, and just do that thing before hearing back from the server. And then if you hear back from the server and it worked, great. If you hear back from the server and it didn't work, you got to roll back and try to reapply or something like that. So these are the types of things that, like, wow, actually this abstraction has got way more to grow into, but is, and I think it also has to come with performance improvements.
Yeah.
Right? If it were just, it's a great abstraction, but like it doesn't work with modern CPUs, that would also not be good. In this case, it seems to be a little no compromise, I have to say, in terms of the sort of the right abstraction matches very well with how modern computers operate. I'm not going to say we got anything but lucky there. So that's kind of how I would approach it.
Well, for what it's worth, I see the vision, and I think from a developer perspective, at the very least at first glance, SpacetimeDB feels very appealing because it feels like the correct abstraction that you would want as a developer. Like, you have a very nice website that shows basically this very simple example of like a very simple reducer, and as a developer, you instantly get your mind spinning on all the cool things you can do with this.
That's exactly what we wanted to portray, and I think we're going to make that even better. I would love for you to be able to edit that code and see it live updating in the website. So you have an application right there, and you can modify your code and see, like, wow, it actually changed the behavior of that application. I didn't have to do anything. And I think we can get there as well. So we got some things cooking.
Nice. Yeah, which brings me back to my awesome list of things I'm already imagining building. I'm not sure if there's like too much to say about it, but I'm just going through it.
Sure.
Also, user-generated content. How do you think about maybe using SpacetimeDB to host user-generated content? For example, I tried Steam solution for one of my games in the past. Like, Steam solution is, of course, a workshop, but it comes with a couple of annoying limitations that are a little annoying to work around. And some games just require something custom. For example, maybe I want to do something like Geometry Dash or Mario Maker, where people can vote on levels in games, or maybe you get an automated queue, or the server automatically like picks the level of the day that got like the most traffic or something. Have you thought about those applications?
We have. We've actually kind of thought, I suppose, one step past that, I would say, into what I call user-generated logic. So let me take a step back. We'll do UGC first. So obviously, since your client is just listening to tables and all of that stuff, you can, in principle, allow players to write models and things directly into your tables, do some validation on them, and then actually stream them down to your client and have them show up in your game. So like things like 3D models and that kind of thing. You can, of course, in SpacetimeDB also build whatever logic you want about the complex permissions you're describing, where it's like, oh, if you're at the top of the leaderboard, you get to be the person who determines the theme of the next game, or whatever that is. We actually want to take it sort of one step further, which is you could make it so the person who wins your game is actually able to modify the code, for example. So you could have logic in your application which says, this person can publish, the person who wins the game can actually publish the next module. So you can even have them modify the code that you actually have there, or you could do things like they have their own module that they've published, which they've registered with yours, and then you can delegate out to them to ask certain questions. So the example I would give for this is, let's say in Bitcraft, we have the concept of an empire, or let's call it an alliance for people who are familiar with other games. So you have an alliance and or a guild. Same idea. What you could do is have that guild give them the ability to upload their own module with an is-allowed function on it. So what would happen is the user playing your game would apply to join somebody's guild. Your module, being the game developer, calls out to their module to say, like, hey, should I allow this person into your guild? That third-party module runs through whatever checklist they have. They're above this level. They've never killed that guy. They are friends with these people. Literally, this Turing complete, sky is the limit. And then if they say yes, they write back into your module, and then you allow them to join the alliance or guild or what have you in the game. So this is a way for you to actually have part of your application be written by third parties, which we think can be very exciting.
Okay, so if you put the correct checks and balances, then you can basically allow your game not just to connect to clients, but basically to other servers that
2 other
users run.
servers.
Yeah, okay.
Exactly right. And so that is a pretty cool thing you could do. And you can imagine, I mean, there's a lot of different ways you could do this. You could have like a bot battle type thing where you allow other people to register their bots, and then you have some kind of a core game, and they're all trying to play against each other. And that could be pretty fun as well. It's more of a programming game, but that's kind of a fun.
That does sound very fun. Yeah, I love all of I love all of your ideas. Like, you have a lot of cool ideas for where this could go. But you've only, like, how much time have you spent working on this so far?
It's a good question. It's hard to quantify because obviously we have been working on it in some part since we started building the game. At the time, we didn't, I think, know exactly what it was going to be. Although I looked back one time because we were looking for trademark purposes, and we mentioned SpacetimeDB like way back, like the name SpacetimeDB, way back, and further than I thought. So I'm not sure what I remember exactly about when we did it, but in 2018 we started building the game. I think in earnest, maybe 2019, and I would say sometime around 2021. End of 2020, we decided like, all right, we're going to make this thing a proper database, this internal engine that we have, which we've been calling, I think we called it actually JankTimeDB because it was SpacetimeDB, but it was janky.
Yeah.
We're going to make this into a proper database and a proper product. So I guess from sometime in 2021, probably mid 2021 until now, we've been working on making sure it's like very well productized and like super clean, nice abstractions. So not just a game engine backend, but a proper relational database. So that I suppose is 4 years ish now, something like that.
So do you have part of your team that just works on Spacetime and part of the team that works on the game, or is it like mixed?
Yeah, the company is almost operates like two separate companies. So it's Bitcraft on one side, who is a client of SpacetimeDB on the other side. It's maybe not quite so clean in some cases because we collaborate very closely. The game's going to go live. We need to make sure we've got the resources and we've done the testing and all of that stuff. Bitcraft is really helpful for us to dog food SpacetimeDB.
Yep.
There's a lot of ideas in it that we've tested out in Bitcraft. Bitcraft has forced us to be very to optimize. Like, I mean, originally when we built SpacetimeDB, you could get like one user into the game and it would take like a minute. But that was for silly, unoptimized reasons. You can very much optimize. We're now around like 1,500 that you can get into one region in the game. So very stark differences between where we started and where we are now in terms of optimization. And I think that's something you only do, practically speaking, if you actually need the performance right now. And so that's something that's been very helpful there. And then also you mentioned like things like analytics that are sort of a throwback to before. So one thing that SpacetimeDB does, and this was at the end of the keynote, I threw this one on there as the one more thing. We actually store the full history of everything that has ever happened in the database, and you can go back in time. That is also not like inter-module communication, not available externally because we want to make sure we get it right for people. But what we have done is like when we had that gold dupe bug that I talked about, what we were actually able to do is go back, find everybody who duped the bug. We weren't guessing. Like we knew exactly who did what by looking at the transactions as they happened and then finding everybody that they traded with. And we traced the money where it went. And if you were sufficiently far away from the dupers, then we just said like, oh, here's a finger wag, like don't do that. Be careful about this. And if you were the dupers or you were complicit with the dupers, you got a permaban.
Okay.
So there is no escaping SpacetimeDB's historical.
And I'm assuming you don't keep all of those records in memory as well. You probably...
No, we don't. So those get written to disk. They get written in the write-ahead log. It's also the same thing that we use to persist everything to disk, where we periodically snapshot the database to make sure that we can restart quickly because you don't have to replay the entire log to get back to where we were. For those of you who don't know, I suppose, a write-ahead log is a typical data structure in databases. On disk, it's append only. You just add transactions, and you use it so that if your machine crashes, you know exactly where you were in terms of processing. So you can come back up in the same state.
So you say Bitcraft supports up to 1,500 players in one region, something like that?
Correct. Yep, about that.
Does that depend on what kind of game it is, or is that sort of like let's for example say I just make a leaderboard. Would that behave differently, or what's your take on that?
Yeah, that's a fantastic question. Yes, it's incredibly dependent on the game. So if you have a chess game, I imagine like you could probably have. Typically, I think you would probably create different databases for different matches in chess, but it's up to you. If you put them all in one database, you could probably have. I think we would fall over on a different thing. So like maybe too many connections, but like because people are only doing actions every so often, hundreds of thousands, millions, maybe. I don't really know. To be honest, we haven't tested it. I think we would run into some other resource constraint other than the one we run into with Bitcraft. So yes, it's very dependent. A leaderboard, same thing. With a leaderboard, you can have very few writers and many, many readers. Yep. And it's a small amount of data. Like in Bitcraft, there's hundreds of tables that you subscribe to. So it's because there's trees and there's timers and there's inventory state and trades and movement and boating and wind and all this stuff that exists in the game. A bunch of UI elements too. Health and stamina and all of this. This is quite a lot.
Yeah.
But in a leaderboard, it's just one table.
Yeah, I see. Okay.
I would be shocked. And there's no joins. Joining is also a thing that requires careful optimization, and we have done some of it. So I think with the leaderboard, you get up to a couple 100,000 as well. It would be my guess.
Right, and that's of course not in entries, but in concurrent users connected at the same time.
Concurrent connected users, that are subscribed.
Yeah, interesting. I mean, I'm curious about the bottlenecks, and I'm sure you'll find more of them as time goes on. And
yeah, I think that's the other benefit of a generalized solution is that it's very complicated to get it all right. So if you build your game and you put in millions and millions of dollars because you want to make an MMO, you've really just optimized it for just your specific thing. And if you want to then reuse all of that work and energy and time and money that you put into it, it doesn't really translate. Whereas because SpacetimeDB gives us the responsibility to do all of the query evaluation and the subscription, we can optimize it. And the more we optimize it, the more everybody else benefits. And the more we work on it, the more games we do, the more different applications we do, the better it gets. One interesting example, talking about abstractions going way too far. Somebody built video calling over SpacetimeDB. So audio and video being passed through the database in real time. I'm not going to lie to you, it wasn't amazing, but it does work. And I could actually send you a link to that if you're curious. Of somebody doing a video call over SpacetimeDB. I think we could make that kind of thing actually work properly. I would never have thought of it, but now that they've done it, I can actually see the path to how we would do that. You probably couldn't use WebSockets. You'd probably want to use UDP, and you'd want to do some fancy things. But that's all. It all fits with the abstraction. None of it's counter to the abstraction. We want to think called event tables. We actually want to do that anyway. But if we had all of that stuff, I think we could actually do video call over SpacetimeDB.
I see. So you have a very, very long roadmap for SpacetimeDB already.
Very long, right? An infinite roadmap.
Yeah. Cool. And do you think you'll have a long enough breadth to make all of that cool stuff happen?
Yeah, it's a good question. So I think that depends on whether or not we can make SpacetimeDB the easiest way to build applications. If it is a no-brainer to pull SpacetimeDB off the shelf and just slap it into your application, then we're going to have some substantial adoption. I think it is a very powerful abstraction. I don't know that. Certainly, I wouldn't build any other game that was multiplayer personally than using SpacetimeDB. We'd like to make it so you wouldn't build any app. So an iOS app, an Android app. I have sort of a theoretical app that I talk about called iScream, which is imagine that you had an app, very simple. You open it up, there's a button, it says ice cream, and you can scream for ice cream. And then ice cream trucks in your area will hear about it, and they are able to bring ice cream to you. It's it's kind of like Uber, but for ice cream. Very simple to build on the client. You just have a button, and it lets people know. And then maybe for the ice cream trucks, they have a map, and I have a heat map. On the back end, if you want to do that today, it's going to take you a while because you got to hook into map APIs and have all the synchronization of like positions in real time and have permissioning so people can't quite see where people are, and you have to spin up a server. It gets complicated, and you got to do WebSockets. The goal is for that to take the other hour. So you do the 1 hour on the front end, 1 hour on the back end, you're done. You've got an ice cream going up. And so I think it comes down to we're going to get adoption if we can make it easy. And it's not quite there yet. I think there's some very cool things. And that is our number one goal. So it's eliminating all of the sidecar services you need and making it so like it is one click. Like you basically can't end up on our website and not make an application. That's the goal.
Okay, I see. And that's also part of the list of things that excite me, like the opportunity to not only write games with this, but to also write some of my own applications with this. For example, I oftentimes have like frustrations with my calendar app or something like that. I'm just like, I don't know, maybe I'll just be able to code something like this up, maybe vibe code it, if LLMs understand your framework, which they probably do. And then
this is an interesting question. So I guess 2 points on that. One is I often see in applications weird state mismatches because maybe the client's not quite in sync with the server because they're doing some poll-based or pull-based thing, and you got to refresh the page. SpacetimeDB eliminates all that because it's just getting streamed down to your client, right? So you just don't have to think about it. And I think that's an important aspect of not only does it make it easier, but it makes it better. And so that's a really cool thing. And then you mentioned sort of vibe coding and AI and LLMs. So one of the hardest parts for LLMs to do is infrastructure because it's not text. They make text and it's not text.
Yes.
The input to SpacetimeDB is just text, right? It's just your module. It's very straightforward. The AI can see your schema. They know exactly how it works. They know the API is very standard, right? It's not as if, I have to do your personal API. It's just a regular API, and they can just use the exact sort of same template. And then on top of that, all it has to think about is one reducer at a time. We had no idea that this was going to be good for LLMs, but we knew it would be good for people, right? If you just have to reason about one piece of code at a time, it's going to make it much easier. It turns out that's very powerful for LLMs as well. And on top of that, because it's a transactional context, if the LLM throws an error or something, it's going to back out. And it can reason about that much, much more clearly. Again, we built that for humans, but it turns out it helps for LLMs too. So the interesting thing is, the code that LLMs can write is becoming more and more ubiquitous. The code that LLMs can't write is becoming more and more valuable.
Yep.
And so I think that's an important aspect.
Yeah, I 100% see that. Yeah, because as you said, the infrastructure is always the difficult thing. If I'm like, I want to host my own password manager, I'm like, okay, what do I use for the backend? Just having a simple solution where I'm like, okay, I just need one table with the passwords. Maybe I have my own way of encrypting them, so I can be very sure they're secure on your server. That's
exactly right.
Sounds very, very appealing for sure. And as you mentioned,
I think I'm incredibly excited. We have the resources to do it. We have the time to do it. We got to be fast. We want to make sure that people can do this. As far you can obviously use SpacetimeDB today. We want to shave off a couple of the rough edges, and I think that's going to unlock things. Maybe we'll do. I'm going to try and write an application, once a week and see how much easier it's getting. That's the point.
I see. Well, obviously there are some companies trying similar things, right? There are other databases, but it's like, what do you say? I guess the question is, how is Spacetime different from the competitors that are currently out there? Because I know there are some databases that also allow you to run server-side code, basically.
Supabase has they've got Firebase. They're spiritually similar to SpacetimeDB in that the idea is like, hey, why are we doing all of this infrastructure? Like, why don't you just take your thing and upload it? I think Vercel is even spiritually similar, right? It's like I was doing a demo for SpacetimeDB and I needed to deploy a version of my app, and it literally took me 1 minute from signing up to deploying the app. I was like, A+ Vercel, great job. This is what I want. We just don't have the same thing for state. So Supabase does have that. You can have cloud functions in Firebase. You can have cloud functions, but it's not. They're kind of they're sort of like store procedures. They have similar problems. You do them one at a time. You upload them. They edit them in the UI. They're not in Git exactly. There's a bunch of latency, so you're constrained in the types of applications you can make. I would love to see them do more in that space. I think I'm just trying to get us out of this hole that we're in. But there's nothing that's quite like SpacetimeDB where you're unconstrained in terms of what you can build all the way up to an MMO. So it's not like, oh, hey, I have a Firebase project, but as soon as I get over 500 users, now I have to rebuild it in something else.
Yeah.
Or whatever the case. That's maybe a little low for Firebase, but you see what I mean. You can go all the way up to an MMO. You can do real time, so you can do games. You can do drawing applications. We've had people do that kind of thing. And you can do just sort of regular apps that have updating data. And I think that is the power. It is a one-stop shop for what you want to build.
Got it. So I guess from what I can see, what makes it unique is that it sits on top of the data and therefore allows you to do very fast real-time. Or are there any competitors that do that kind of stuff?
Not that I'm aware of. Not that are as general. Like obviously you mentioned Photon. They have like Photon Quantum, and they have Photon.
They have Fusion, but obviously I think they're very, very different because they're like purely focused on real time. They don't have, from what I can see, they don't have any persistent databases.
Yeah. And that's the problem that we ran into. Actually, it's why we built SpacetimeDB in the first place. I'll just go over that briefly. Kind of like where was my head when we were thinking about building this? Because we didn't want to. We wanted to build our game, and we looked at. There's like all the web solutions, they couldn't work, right? They're just way too slow. They're not related to games enough in terms of like the performance requirements. It's really performance requirements and also some of the design of how the server works. And then there were all the game solutions. And the game solutions were like, there was, what is it called? Improbable was making a thing called SpatialOS, if you remember that. And there's things like Photon, I think Photon Quantum was a thing at the time. And the problem with all the game solutions, they didn't deal with persistence and storing the data, right? So SpatialOS, which I think it probably got like $600 million in funding. We were going to build our MMO on them. It was going to be expensive. And then they're abstract. They didn't really solve the problem that we had to solve. Like our game requires a lot of persistence. Building buildings and changing the terrain and keeping the trees that you cut down and all of that stuff. And we would have had to have done all of that anyway. So we would have had to have coordinated with a database. So that wasn't really a great solution. And then you look on the other side, well, the web apps have the persistence, but they don't have any of the stuff that the games app has. So I was thinking like, is there a way that I could unify this so that we could have something with persistence like a web app, like Facebook, right? Facebook, if you squint very hard, is an MMO.
Yeah.
So I wanted that aspect of it, but I wanted to be able to do the real-time part of it. And there was nothing that could do that. So we put them together.
One thing that we didn't mention yet, which maybe we should just briefly mention, is that you can also schedule reducers, right? They don't have to be called by a user. So you can do things like you can basically have a server tick rate by just scheduling a reducer to run every 60 times per second, 30 times per second. I assume for an MMO, you probably can get away with a lot less, right?
So with an MMO, you can get away with a lot less. And actually, in our case, I don't know that I would redo it. There are trade-offs. Kind of depends. But in Bitcraft, there is no tick rate. Actually, every time you move, we do a transaction in the database, and we move your player.
Okay.
Interestingly. So you actually, that was another thing. I was like, all these game solutions, they have, I'm required to have a tick.
Yeah.
And in web, like I can't have a tick or it's weird. And I wanted to make it so I could have a system where I could choose to have a tick or I could choose not to have a tick or I could have multiple different ticks. So I could have like an AI tick and I could have a whatever tick and we could do this differently. So with scheduled reducers in SpacetimeDB, they're just normal tables. So basically you have a scheduled table and that scheduled table has rows in it and they call reducers when the time elapses. The really cool thing about that is you can SQL query all your timers. So you can say like, hey, I want to debug what's happening with my scheduler. SQL select from my timer table. Bam, I've got all my timers. I can see exactly when they're going to expire. And I can delete them and I can insert them. That was a real eye-opener when we did that one. Like, okay, now we're cooking. This is really good stuff.
Yep. So the timers as well are just a table. Everything is tables.
Everything is a table. If Unix is everything is a file, in SpacetimeDB, everything is a table.
So next on my list of exciting things that I might want to build. I also already briefly mentioned this, but maybe we can go a bit more into depth. It's like a matchmaking. Let's, for example, say I really like Photon Quantum solution for real-time multiplayer, but they don't have the type of matchmaking that I want. Do you think I could, for example, combine different systems and, for example, use Spacetime for matchmaking and account management stuff and sort of pair it with other networking solutions?
So you certainly could. And that's what games actually have done. I was supposed to have a meeting with somebody yesterday who are using SpacetimeDB as a matchmaker for their game. The game has overwhelmingly positive reviews on Steam. I don't know. I haven't talked to them yet, so I don't know if I want to shout them out if they want me to or not. They probably do, but I don't know.
You can shout them out now and tell me in hindsight. I'll just edit it out.
Okay, that's actually a great point. So let me see. The game is Underdogs VR. And it's by One Hamza, and they have that game on Steam. It's $30. Check it out. Overwhelmingly positive reviews, with almost 2,000 reviews. 97% positive all time, and they have decided to use SpacetimeDB specifically for the matchmaking aspect of their game. So they do whatever they want on the side, and they do matchmaking there. You certainly could use it with Photon Quantum and Photon Fusion. There's probably cases where that makes a lot of sense. Matchmaking games, especially where you have full knowledge of the game state with Photon and Quantum, is what you need. So you could do something like that. The cool thing about SpacetimeDB is that it fails safe, is what I would call it, to Postgres. And actually, we're about to also release Postgres wire format. So you will literally be able to connect to it as though it were a Postgres instance with like PSQL and do Postgres type stuff. So it has way more capabilities than that. It also doesn't have all the capabilities of Postgres. I want to be clear about that yet. So there's kind of a long tail of random Postgres things to do, but it will sort of superficially seem very much like Postgres. And then also we have the ability to subscribe to the data, and we have the ability to run your application inside of the database. So you can use it if you don't want to drink the Kool-Aid. You can have just a little sip, I guess is what I would say. And that's one of the cool things too about the abstraction.
Yeah, because there are not really any solutions that offer very customizable matchmaking. Like the best you can get from out of the shelf is maybe you attach some metadata to your lobbies and then you search for specific lobbies, but that's kind of the best out of the box matchmaking you'll get. If you do like if you want to do a league system or something cool like that, then there's not really anything like that.
One of the cool things I think also about SpacetimeDB is that because the code comes in such a standard format of like, hey, I have these tables and then I do this, certainly somebody can create a library and then share it around in a way that you can't normally. Like, oh, if I have a matchmaking system, well, it's like specific to my AWS deployment. And like, I can't spin up the matchmaking system without also like the Kubernetes deploy and all of that stuff. With SpacetimeDB, we could do the matchmaker code and just have, bam, that's a library that you just import, and now you just use the matchmaker. We haven't done that yet. I think the community has done some really cool things. We're going to be putting something on our website that's going to encourage people to sort of share those things a little bit more, so that we can get some like standardized, hey, if you want a matchmaker, just pull it off the shelf and then customize it, right? Just change it however you want, add tables, remove tables, do whatever you want.
That was cool. But even like before I found Spacetime, I didn't even really have an idea of how to write something like a matchmaker. And now it's like the first time that I can imagine a way to do it, right? So that alone is already kind of cool.
That's very gratifying to hear.
And also, obviously, we've already mentioned asynchronous multiplayer is probably also a very good use case for Spacetime. If you have like turn-based things like chess, or maybe you have something like the Supercell kind of games like Clash of Clans, where you build up a base and then you can raid other bases and stuff like that.
Yeah, absolutely. Those are great because you need the persistence. In some sense, it was inspired by that. So I used to work at a company called Machine Zone, which was a direct competitor to Supercell. Supercell is one of our earliest investors, actually. They are, I think, the earliest investor who put in the first money. And the way that happened is I worked for Machine Zone, and Machine Zone was sort of very monolithic and top down. But Supercell is called Supercell because it's a collection of these little cells. I thought that was so interesting. So I reached out to the CEO and I said like, hey, this is really interesting. I used to work at Machine Zone, curious to know questions. And at the end of the call that he set up, I said like, by the way, we're making a game. This is what it is. And he passed me off to their investment department. And that's kind of how the whole thing got rolling. So SpacetimeDB is largely inspired by my time at Machine Zone. And in particular, some of the data analytics stuff. So I was on the data science and data platform team. they were always trying to reconstruct this historical data.
Yeah.
Because they wanted to be able to predict, like, what is this user going to do and so on. And it's very hard to append it on after the fact. So with SpacetimeDB, I wanted to make sure I always had it from the beginning and that it was a minimal amount of data and that we could do sort of arbitrary analysis on it.
Right. That's why you store the entire track record of everything.
That's exactly right. That's where that came from. But their game, I say all that to say that their game was much like Supercell's games, asynchronous.
Yeah.
They were asynchronous city building games.
I think there's still a ton of untapped potential in asynchronous multiplayer. I think the reason why there aren't a lot of games like this is because they're difficult to make. So
it's hard.
Indies don't really make them.
Yeah. And the back end of a game like, I don't know Supercell to be frank, but at Machine Zone, the back end was more like a web server than it was a game server. It was sort of like a web server with some stuff added on and kind of hacked on to make it a little bit real time in certain cases.
Yeah.
And it took a lot of people to build. I think that took 80 people to build that game.
Yeah.
The original Game of War game.
Yeah. Obviously, some requirements might shift as like if you have a game at Supercell scale with like millions and millions of players, then obviously maybe your backend has some extra requirements probably that make it everything maybe a bit more difficult.
Yeah, that's true, but I think you would also be surprised at how much computers can do and how strung together with duct tape and wire some of these larger things are. Machine Zone used PHP. It was very slow. I remember we did the math one time, and I think they had like 2 users per core CCU or something like that. That was particularly inefficient because I think they owned the data center and they had to rent a bunch of machines. But I think with SpacetimeDB, it would be much, much more efficient, and you could do a much larger set of users on a smaller number of machines.
Sure. Obviously, efficiency is also not just about how efficiently does it run, it's also about how efficiently can you build it, which is arguably in some cases even more important.
It is. They're both important.
Yeah.
I think you can't sort of just take one without the other. I believe that with SpacetimeDB, we make it both more efficient to run and both more efficient to build as well. That's the goal. I think if you just focus on one of those, you get into not great places.
Let's quickly talk about your free tier. So one thing that I also found interesting is that you pretty much allow self-hosting out of the box, right? So if I'm not interested in paying you a single cent, I can just self-host immediately and go from there, basically. Or how does that business model work exactly? What's the idea and the reasoning behind this?
Yeah, so it's a good question. First thing I'll say is very soon we're going to be transitioning to also make main cloud have a free tier. So you'll be able to deploy to main cloud just no problem. And for most developers, they'll never have to pay anything. So we're going a little bit more free than we currently have on the website. With respect to self-hosting, the idea is there are a couple scenarios where we don't really want to restrict people from just building things. So one is if you're making a small thing, like a sort of a non-commercial thing, or even a commercial thing, but it's somewhat small. We want people to be able to host their own version of SpacetimeDB, partially because with intermodule communication, we want to be able to connect all of these clusters together and have sort of an internet or ecosystem of a bunch of different SpacetimeDB. We don't want to be the only one in town, which is why we called our cloud main cloud as opposed to just cloud. Because we want ours to be the main one, and then other people can connect to it and add their own stuff by running their own hardware on the side. We also want it to just be easy to run in development on your own machine locally. So it's very easy to run, especially if you have the source. You can build it from source. You can make modifications. You can contribute back if you want to. And you can run it locally in development. So we want you to be able to deploy small things in production, run it in development. We also don't want you to restrict shipping it to clients, to like users, if they run one, right? So you can imagine like if we were to do the client-side prediction thing where we're actually executing SpacetimeDB on your client, we want people to be able to do that. We also want people to be able to do peer-to-peer stuff, right? Like if you're not operating the servers, we don't want to have to charge you a license or that you have to be concerned that we're going to come after you because you're running it, whatever. We just want that to be something that you can do. So the business model really comes down to if you don't want to do infrastructure, use main cloud. It'll be great. It'll scale. So if you're a serious business and you don't want to deal with infrastructure, main cloud is your bet, and that is our business model. If you are a developer who's just messing around, or somebody who's building something small, or someone who doesn't mind putting in a bunch of legwork to do infrastructure, then you can do standalone, and that's how that works.
So the tech is kind of free, probably with some limitations on what you're allowed to do, but the business model is basically just the infrastructure. So tech is kind of free.
To clarify, the license is basically,
Yes.
so here's what the license says.
Yeah.
The license says if you run one node, you can do whatever you want with it. Modify it, run it, do whatever you want with it, no problem. If you're going to make a clusterized version of SpacetimeDB, then you need to wait 4 years before it becomes open source, like fully open source. So it's source available, and there's a 4-year like lockup before the actual thing becomes. You can do whatever you want. So you can run a clusterized version. You can resell it as a service. It's an anti-AWS clause. That's really what it is.
Okay.
So AWS can't take SpacetimeDB, run it in AWS, and then charge users for it.
Yes.
But we build it.
Okay, that makes sense.
That's the idea. And then we have internally a private version, which is clusterized already. So it requires no modification. It's already clusterized. And if you have a large client, if we have a large client, we can either run an on-prem installation for them, but in the vast majority of cases, we can give you like dedicated nodes on main cloud or just a shared node on main cloud, and you can go to town on there.
Got it. So, and the 4-year delay basically applies to all of the updates you do as well. So there's like always a 4 years delay on everything you add, basically, or how does that work?
There is, yeah. So if you want to resell it as a service or run a clusterized version, you need to wait 4 years per version.
Okay, got it.
If that makes sense.
I think that sounds fantastic. Like that is kind of as open as you can get without harming your own business model, right? I think it sounds very good.
That's essentially what we thought as well. We wanted to go right up to the line where, and I think there's a world in which, depending on how things go, we just say like, hey, single node is fully open source. We have the clusterized version. That's the deal. I think we're waiting to see what the adoption looks like. Are we concerned that AWS is just going to run like AWS SpacetimeDB and then we'll be sad?
Yeah.
That's kind of what we're thinking about.
Yeah, I see that. But it really helps to take some of those typical developer fears, which are like, what if they suddenly shut down their servers and so on. It's like, and also like conserving games for the future, making sure they're still playable.
I think it's a very real and important concern for any game developers. You want to know you're going to have this thing around. I mean, SpatialOS, right? A lot of people went all in on SpatialOS and then they stopped supporting it. And people had to figure out what to do. And no matter how much guidance and help you provide, that is not great for your business in games, which are already pretty difficult as it is.
Do you want to maybe take another, 20 minutes to talk about Bitcraft a bit more? Because I think that's also quite interesting.
Sure, happy to.
Awesome. So entirety of Spacetime was basically created as a tool to create the game.
That's correct.
So the game was first.
The game was absolutely first. Yep. Well, I don't think we would have had the idea for SpacetimeDB without the game.
And then somewhere halfway through, you realized, this would make for a good standalone product.
Yes. Again, I don't really remember when that was because I thought it was later, but then I looked back and we had it in like our earliest materials. So it might have been, I don't remember exactly what my mind was, but at some point we saw, hey, this is a database. And then further we saw like, this is a database that we should release externally because it's in some sense certainly if you're a developer, it's the more exciting product. If you're a gamer, obviously the game is more exciting. But
yeah. All right. So what was the idea for Bitcraft? Like certainly it already started out with quite some ambitious plans already, right?
Yeah, it did. The idea was, in essence, it went through transformations. At the beginning, it was a little bit more of like a mobile game look. In fact, you can actually probably look and find some of the old mobile game looking UI and things. And it was meant to be a little bit more asynchronous. But the more we built it, the more we thought like we should turn this into a proper MMO. And the main inspirations for Bitcraft were Minecraft, obviously. So you can, it was a survival game. You can modify the world. You can build roads and things. But then we wanted the long-term progression and free trade economies of old school RuneScape and EVE Online.
Mm-hmm.
So old school RuneScape is an inspiration for the control scheme and the skilling and all of that stuff. And then EVE Online for some of the trade, obviously also old school for some of the trade, but also like the empire system in EVE Online, the sort of the very big scale social system where people are vying for power was a cool sort of layer to add on top. But the idea generally with Bitcraft is that everyone is working together to rebuild civilization from the ground up. And then that takes a long time and that's very meaningful. If you see somebody walking around, took them several months to get something, that should be impressive. So that's where the game came from.
So I think you can still see some of this idle game nature in the game, right? I checked out some reviews and trailers and stuff, and there's still some tasks in the game that like take a really long time. For example, like you saw some wood or you plant some seeds, and there's like it's not something you'll actively sit through all of the time. Maybe you'll grab a snack or have it run on a second screen. Something like that.
That's right. And that's as designed. I think the thing is when you're a small company of small amount of resources, you need, we needed the progression, we need the content, we need people to be there. It's an MMO, so you need people to be there for a long time. But also the waiting and the dedication to creating a thing is what makes it valuable. I think a lot of teams over time forget that because people want the things. And so they'll shout loudly, like, I want the things. But if you make it too easy to get the things, they're no longer meaningful. But with a small team, what you first need to build is you build a skeleton, and then you add flesh to it over time. And we've added some, but there's a lot more. So we want it to be that, hey, I can do a thing idly, or if I want to play the game actively, I can go play the game actively. And I think that's something that RuneScape has gotten really, really correct. They have the long-term progression. They have the more idle gameplay. They also have, I can go fight a boss. I can go do a quest that's fun. I can go talk to people in town. I can do kind of whatever I want. And I think it's that mixture that is the important component. And we absolutely have plans to continue to make that mixture more exciting and to grow. I would give the example of like, I don't know if you've ever seen, but they have these things like forever stews where you make a stew and every day you add new ingredients and it changes the flavor of the stew and it gets better and better. It's kind of like that with MMOs. They start out pretty bland, a little bland, but over the course of 10, 20 years, they become a rich, complex flavor of different things. And I think that's where we want to go.
So you've set out to create two very, very long-term projects, like both Bitcraft as well as Spacetime are like...
That's right. We're here and we'd like to be here to stay.
Yeah, cool. I checked out some of the Bitcraft reviews, of course, and one thing that struck me as kind of interesting was that a lot of the negative reviews are from people who've spent a lot of time in it, right? Like if you check out the negative reviews, it's almost always like 100 hours plus.
Yes. I mean, we got a couple like 900 plus hours. And those kind of hurt my soul a little bit.
Of course.
Because like, you spent 900 hours here, but here's the thing. They leave good feedback. It's useful feedback. It's more useful feedback in some sense than somebody who comes in and just says like, it's not for me. Because we know this is for them. And we can then work on it and improve it. And I think the thing is, if you spend 900 hours in it, there's something in it that you like. And usually you leave because there was something that happened that you didn't like. And I think that means it's fixable in those cases. And we can bring people in. Again, you taste the stew every day. You see how it's going. And you add the missing ingredients.
Yeah, it's interesting. I also talked to Ben, like someone from Tipsoft. They also make MMOs. They made Tibia. I talk to him a lot, not just on the podcast, but also on random events where I keep meeting him. And one of the things he told me was that they're trying to get people through the progression system almost like kind of as quickly as possible, because the people want to get to the end game. So they want to get people to the end game as quickly as possible.
It's classic.
I think that's also an approach you can go for, right? If people say it's too grindy, you maybe try to find a way to tone down the grindiness a bit and find a satisfying end game that people can play, which is like trade wars or waging wars against each other, where they burn resources and have motivation to craft new things and so on.
this is intentionally something that we're not going to do. And we're not going to do it because there are plenty of games that do it. Like, if you play World of Warcraft, they'll wipe your progress every year when they do the new expansion, basically. They'll make everything you did not meaningful and you go do the new thing. And you can pay, I think, $60 to skip through all of the first however many levels and get to the end game. That is fine. I mean, you can make a game like that. It's the most successful MMO probably of all time. But it's not the type of game that we want to make. So we want to make RuneScape, not WoW. And I think the thing is, if you do that, right, it is true that you can get people through the content faster to get to the end game. But then I would ask, I guess, why do you have the beginning game if people are just trying to get through it? You might as well just make just the end game. And I think you have a better game, personally.
That's a fair question, yeah.
And I think in our case, what is interesting about RuneScape, right, is that people who are just, and a lot of people are now just discovering old school RuneScape. It's had a huge resurgence. I think it had the highest CCU it's ever had a couple of days ago, if I'm not mistaken. The cool thing is that all of the old content that they built 20 years ago is still relevant, and they modernize it and they improve it. But it's not as if, I'm skipping past Onyxia because there's literally why would I even bother in World of Warcraft to do all the old bosses when it's all about the new stuff? And so what I think is important is that when somebody sees a piece of armor that you're wearing and they know it's high level, as soon as you make it easier for somebody to get, it just cheapens it.
Sure.
It just cheapens it massively. And so, I said, I don't think you can't build a game that way. I think that's exactly what World of Warcraft did. And again, I think it's the most successful. And I think it's just not where we want to go. I think we'd rather go the RuneScape route.
And because also your entire world is modifiable and you can build in the world, you don't want that to be cheap. You want it to be meaningful. Like every stone that was placed was you can know that effort was put into this. Like if you see a cathedral, you know that it costs something.
Exactly. You kind of need to, even as a balance question for a modifiable world. Otherwise, I don't know if you've heard of the Minecraft server 2B2T. It's an anarchy server. You can do whatever you want. But if you spawn in, the spawn areas are dystopian hellscapes because people have just modified it. And we want the world to feel like a real world in Bitcraft. So it does need to be time consuming to build a road. Otherwise, there's going to be just,
roads
parking
everywhere.
lots as far as the eye can see.
That makes sense. Yeah, what have been the main challenges you've run into developing this game, and how are you tackling them?
There's a lot. It's hard to go over them in a short amount of time. I would say one of the hardest things about Bitcraft is you can't just balance it at a point in time because the game world changes over time. So you have to balance it across the life cycle of all the players that are going to play it. So when you first start, nobody's built anything. But by now, there are cities that are sort of very high tier, 8, 9, tier 9. And so the game today is different than when it was created. With World of Warcraft, not so, right? The game is the game and it stays the same and people go up in level, but fundamentally the world is not changing. And that is very tricky to do. I think also getting the population density correct is very tricky to do. So you need to get enough players close together that they can trade, but not so many that they're stepping all over each other and they can't build and create what they want. And that is a function not only of deciding what's the scale of the buildings and the players and all of that, but also how quickly they can travel. If I give you the ability to teleport all around, I immediately shrink the world down functionally. But you still want people to be able to trade and have different prices in different areas. So you can do arbitrage, you can bring the logs from place A to place B. That is very tricky to do. We're just kind of getting into the places that other MMOs sort of start from. So improving our combat. I think that's something that we have not, I shouldn't say we haven't invested a lot of time, we have, but it's not been the main focus of what we're trying to build. So I think doing it now, adding to the richness of the stew requires a slightly different set of skills than maybe at the beginning when you're adding the meat and the potatoes.
And then obviously you have the typical challenge of the game's already running and you need to find a way to update the game without alienating the players that like it the way it's now.
That's right.
So it's always
that's very hard. And that's how you get 900 hours in a bad review. So it's challenging. I mean, we've had things where we push out things on a preview branch and people were like, oh my God, I can't believe it. But we push out bugs on the preview branch. People are like, I can't believe they are so dumb as to do this. And it was it's a bug. we're going to fix it. That was not intentional.
Yeah.
And then we do fix them.
Yeah.
But yeah, it's true. It's very challenging. And I think the thing is, you try it, you get it wrong, you fix it. You try it, you get it right. Some people don't like it. You strike a balance. It's just, there's not an easy answer. I think you just have to be committed.
I see. So is Bitcraft mostly a game about resource management and trading, or what is it specifically about? Is it a game about simulating civilization? Is it a game about simulating trade? Like what's like the core identity of it, you say?
It's a game about simulating civilization. I don't think you could say it's about resource management, because why don't you play, an RTS, like a sort of a single player RTS, play City Skylines. It isn't about just social stuff, because you have to do the logistics and plan it out. It isn't about going and killing monsters in survival, although you need to do that as well. It's really about civilization in all of those aspects. So the fact that you do need to do resource management, and you do need to negotiate with other players and build friends and meaningful relationships. One of the coolest things I've seen in Bitcraft is that people actually meet friends in the game in a way that I think you might not do in a matchmaking game, because you're not spending as much time with the same people over and over again to work towards a shared goal as what you do in Bitcraft. I've had people, before even the game was released, they would say to me, like, thank you for making Bitcraft. And I was like, hey, let's release it first before we start thanking me. And they said, like, no, you don't understand. Like, I met my girlfriend and my best friends in the Discord servers about Bitcraft, talking about the game.
Yeah.
And I said, okay, I didn't have that context, but that's very rewarding.
Yeah, so the main content of an MMO is oftentimes the communities that form in it, right?
Absolutely, and I'm very proud and happy with our community. I think they do an amazing job. People mention, you can see in the Steam reviews, it's a very welcoming and it's an amazing community. And in some ways, I think it delivers on the promise of social networks that social networks never did. Most people don't make new friends on Facebook. They don't make new friends on Instagram, but they do make new friends in our game. So
games are a good environment to make new friends, because you instantly have something to talk about and a way to interact, and like you instantly have a connection point. Yeah,
for sure. It's in some ways, Bitcraft is a chat box with a reason to be talking to people.
Obviously, one thing that I've found is with selling games on Steam is also that a lot of the art is in expectation management, just making sure that players know what they're getting into. For example, like if somebody downloads Bitcraft and they think it's like a combat-focused MMO or something like that, they'll probably be disappointed, right? So setting correct expectations is quite important and also quite difficult.
It is, and I think we could do better on that as well. We've tried. It's challenging. But I also think MMOs are particularly hard because everybody has an idea for what they want in an MMO, and the category is so broad that it encompasses quite a lot. And so they come in with hopes and dreams, and we do our best to fulfill them. But we can't always. And I think day by day, we'll do more and more.
Cool.
Awesome.
I think we'll leave it at that. I think it was very, very interesting. All in all, I want to thank you again for taking the time. It's really fun and insightful chat. And as mentioned,
Thank you so much for having me.
You're welcome. I'm excited for what you build, and I wish you good luck. I'll just stop the recording there, and then we'll
Thank you so much.